Multiplying and dividing exponents. Let's get rolling. When performing operations like multiplication and division with exponents, there are several rules that make the work shorter and simpler. Hopefully you have some experience with this, but if not, here we go. When we're multiplying exponents with the same base, you add the exponents. Here we have an example of x to the a power multiplied by x to the power b. That equals xa plus b. Let's see here. So if we had 5 to the second power times 5 to the third power, wow, where'd that line come from? As long as the bases are the same here, 5, 5, this is going to equal 5 to the power of 5 because 2 plus 3 equals 5. If x were to the power of 4 and this x were to the power of 6, 4 plus 6, this would be x to the 10th power. Okay. So let's look at a bigger example. Oh, here, example, x to the power of 3 times x to the power of 4. This is essentially saying x to the third power is x times x times x. Multiplying that by x to the fourth power, which is x times x times x times x. That's going to give us 7 x's here, give us x to the 7th power, which is the same thing as x to the third plus 4th power. So let's try an example. We have 2 times a to the 23rd power times 3 times a to the 17th power. So we do have the same base here, and we can simplify the outside, right? And here we essentially are going to have 2 times 3 times a to the 23rd power times a to the 17th power. These bases are the same, so we can use this rule up here. 23 plus 17 equals 40. 2 times 3 is 6. Keep the base to the same, and we end up with 6 times a to the 40th power. So we're multiplying exponents. If the bases are the same, we can simplify it from there. Dividing exponents. When dividing with the same base, you're going to subtract the exponents. Here in the first example up here, we have x to the a power over x to the power b, and that equals x to the a minus b power. So let's go to our example. X to the 5th power divided by x to the 2nd power. Our bases are the same. This is essentially saying to us x times x times x times x times x over x times x. When we're dividing, whenever we see something that's the same, we can eliminate those things, right? This one is being eliminated here, and this one's being eliminated here. X divided by x is 1. We don't usually keep the 1 on the bottom. If we're left with 3 x's left over here that are not crossed off, our final answer would be x to the 3rd power, which would be x to the power of 5 minus 2. And I got that from right here. All right, so a couple different ways we can show that. So let's work on dividing those. Here in this triad problem, we essentially have 6 being divided by 2, and we have x to the 8th power divided by x to the 4th power. I know we can simplify 6 over 2, and x to the 8th over x to the 4th. Remember from our example here, we end up with x to the 8 minus 4 power, a minus b, top divided by bottom. 6 over 2 is going to be 3, and the x that's left over is to the 4th. So the simplified version of 6 times x to the 8th divided by 2 times x to the 4th is going to be 3x to the 4th power. Let's look at one more example before we move on, because this is definitely going to happen. M to the 10th divided by m to the 12th. Well, if we use this example here, that equals m 10 minus 12. That's going to equal m to the negative second power. We don't ever want there to be a negative exponent as our most simplified answer. So now I'm going to teach you what to do in that situation. Negative exponents. When a number is raised to a negative power, that's the same thing as a 1 divided by that number to the positive power. Okay, so here, the example in kind of reddish color, x to the negative a power equals 1 divided by x to the positive a power. So that example we just did, where we have m to the negative second power, that is going to equal 1 over m to the second power. We always want that positive exponent there. Let's look at this example here. We have 4 times x to the third power divided by 2 times x to the fifth power. We know that we can do 4 divided by 2, and we can do x to the third divided by x to the fifth. 4 divided by 2, that's 2, so that's nice. And then x to the power of 3 minus 5, using our division properties. That's going to be x to the negative second power. All right, so what we have left here is 2 and x to the negative second power. We don't ever want a negative exponent as our most simplified version. Let me erase some stuff. X to the negative second power is going to equal 1 over x to the second power. That's going to be the simplified version of that. We can't forget this number 2. 2 is going to stay in the numerator, 2 times 1. So our answer for what the most simplified version of this question is 2 over x squared. Let's do the try it problem together. Nine times x to the 8th power over 18 times x to the 12th power. 9 over 18 and x to the 8th minus 12. How did I do that? I see there's division here, and I know that I'm dividing, I'm subtracting the exponents. 9 over 18, simplified, it's going to be 1/2 times x to the negative 4th power. Okay, so what am I going to do here? Well, I have to take care of my x to the negative 4th power. I need that to be 1 over x to the 4th power. When I multiply fractions, I'm going to bring this down, and I multiply straight across. In the numerator is going to equal 1 times 1 is 1. 2 times x to the power of 4 is 2x to the 4th power. So the most simplified version of this try it problem here is 1 over 2 times x to the 4th power. Example 1. 2 times x to the 4th times y to the 7th times 3 times x to the 5th and y to the negative 8th. Let's split up our bases. Make sure we don't lose track of anything. We're going to end up with 2 times 3 times x to the 4th times x to the 5th times y to the 7th times y to the negative 8th. For color coding these, we're definitely going to combine these. Definitely going to add those with the same base and those with the same base. In the green, 2 times 3 is 6. In the pinkish color, x to the 4 plus 5th exponent is going to be x to the 9th. And yellow here, y to the 7th power times y to the negative 8th power, 7 plus negative 8. I believe that's negative 1. And keep the 6 here. We need to change this y. I'll use a different color because that's kind of hard to look at. And that equals 1 over y to the first, or just y. Multiply that 1 by what I have on the numerator. Simplified version here is 6 times x to the 9th power divided by y, over y. Alright, multiplication ended up as a fraction. I know you all love that. Let's take a look at another example. Example 2. Okay. Let's line up all the things that we know we can. So we've got our coefficients here, 15 over 5. The A's match up. The B's are going to match up. And the C's are also there. And if we're dividing, that means we're going to be subtracting exponents, but we keep our division principles. 15 divided by 5, I believe that's 3. Then we're going to end up with A to the 12th minus 6th power, B to the 8 minus 10th power, and C to the 3 minus 1. Notice there's no number 1 there, but I know that if for it to be there, C has to be to the first power. Let's simplify that if we can. A 12 minus 6, we're left with 3 times A to the 6th power. 8 minus 10 is B to the negative 2nd power. And C is 3 minus 1 to the 2nd power. Looks like we're going to need to move 1 to the denominator here. This B example. B to the negative 2nd power. Remember that equals 1 over B squared. So our final answer here, numerator is 1 times 3a, 6th power, c squared over b squared. We can also look back at that first example and just going from top down, 3 minus 1, so positive 2 goes up top. 8 minus 10, that's negative 2. So we know it's going to move down. This c is going to move up. This a is going to move up. 12 minus 6 is positive 6. And then 15 divided by 3 going in evenly means that this is going to move up to the numerator. All right, hopefully that makes sense, and we'll see you in class.